San Diego Global Knowledge University.
Hello, welcome. In this class, we are going to reflect on the role that knowledge and research have played throughout the history of humanity. From the magical and mythical explanations of natural phenomena to the consolidation of the scientific method, human thought has evolved in complexity. Research is not only an academic or laboratory process, it is present in our daily lives, in every question and every search for answers. And it is precisely this ability to ask and to investigate that distinguishes us as human beings. Magical, mythical, and religious thought, how human beings sought to explain the unexplainable. Philosophical thought, reflection on the origins and the essence of knowledge. Scientific thought, Bertrand Russell, and the idea that all knowledge is either particular or scientific. Critical and complex thought, the need to integrate disciplines and analyze reality from multiple angles. Strategic and perspective thought, anticipating possible futures and preparing for them. When we talk about magical or mythical thought, let us think about how ancient cultures attributed storms or earthquakes to the gods. But over time, philosophy and science began to provide more solid frameworks. And today, we need complex and strategic thinking to solve the major problems of the world. Research as a systematic search for answers. Conditions of a scientific problem, well-conceived, integrated, formulated, feasible, theory-based, and with available resources. Types of knowledge: empirical, scientific, and philosophical. The scientific method from Aristotle to Euclid up to modern methodology. A simple example of empirical knowledge is when a farmer knows it is going to rain by observing the clouds. That knowledge is valid, but it is different from scientific knowledge, which requires systematization, verification, and the possibility of being replicated. Are you ready? Let's begin. You spend the whole day looking for your things, your food, your sneakers, the neighbor's WhatsApp, spending the entire day investigating. By general definition, research is something that is sought after. Research has a specific profile depending on the discipline. For example, the field of the exact sciences applies the experimental method, unlike the scientific method that is applied in the social sciences. The differences arise from the nature of the disciplines. While the exact sciences work with inert matter that can be treated in a laboratory, the sciences that study human beings and their relationships investigate changing phenomena. What you believe today may no longer be what you think tomorrow. A single event can lead to a radical change in social behavior. Explanations of the world and of phenomena can be developed through different ways of thinking: magical, mythical, religious, or scientific. Each corresponds to socio-cultural formations at different stages of development. We do not know everything, but neither do we know nothing, and humankind, more than through the pursuit of truth, enters into knowledge out of fear, since the unknown produces insecurity and dread. Thought is a process of generalized cognition of reality. In the act of thinking, we form concepts that reflect, in a particular way, the objects and phenomena of reality. Among these we find magical, mythical, religious, scientific, critical, complex, strategic, and perspective thought. Magical, mythical, and religious thought. When humans sought to explain natural phenomena without scientific tools, they began to create their own explanations through myths and magical practices. This is where mythical and magical thought arose. Fables, legends, and myths were created around events that seemed inexplicable, and human beings responded to them with the resources available. Thus, they believed in magicians, dragons, and heroes. Later, the explanation of events was attributed to the gods, who rewarded good and punished evil. The Greeks and Romans were polytheistic cultures. That is, they believed in many gods to whom they attributed special powers to control human beings in different areas and situations. Other cultures were monotheistic, meaning they believed in a single god to whom they attributed all that was good and bad that happened to humanity. The good-evil duality began to shape religious thought. Religious thought endured for many centuries as an explanation of reality. The problem was that it did not allow for alternative explanations because it had been monopolized by the church and controlled by friars, to such an extent that priests themselves claimed to be possessors of divine truth, which they spread from the pulpit, exercising their influence in newly established communities and even in universities, which bore the name pontifical, meaning related to the pontiff or the supreme prelate of the Catholic Church. The evolution of science opened the way for new actors. Thinkers and philosophers reflect permanently on the origins, the possibility, and the essence of knowledge. They spent hours debating enigmas that remain unresolved to this day, such as, which came first, the chicken or the egg? What do you think? Philosophy took charge of thought and its complexity to the point that someone described it as a blind woman entering a dark room to look for a black cat and finding it. Human beings are characterized not only by solving problems but above all by formulating them. As knowledge expands, thought becomes more complex to the point where thinking in a simple, concrete way, as children or those without access to education and culture do, seems impossible. Bertrand Russell said that all the knowledge we possess is either knowledge of particular facts or scientific knowledge. To know, then, is to establish a relationship between the subject who knows and the object known. In the process of knowledge, the subject in a certain way appropriates the object known. If it comes from the individual themselves, that is, from their own faculties, knowledge may originate from 1. Experience, understood as the perceptions of the senses. 2. Reason, as the capacity for reasoning which allows logical inference from one set of concepts and statements to another. 3. Intuition, or a profound understanding of something through a kind of rapid intellectual vision without the need for deductive reasoning. The need to understand the totality in which different disciplines and their interdisciplinary efforts are inserted has led to the emergence of a new type of thought, which Pablo González Casanova describes as critical thought. One of its objectives is to articulate the different branches of knowledge to see what escapes hegemonic knowledge that is nevertheless significant when trying to understand something, for example, the roots of social injustice or the construction of something like a less unjust world. Nothing is simple anymore. Society and its problems have become so complex that no single discipline can resolve them. Today we speak of problems as entangled networks that require the collaboration of several disciplines. It is no coincidence that the sciences of complexity have multiplied in different institutions. Complexity is a concept that seeks holistic, integrative analyses, because it is no longer possible to understand the world otherwise, nor with a single disciplinary lens. To deal with complexity, an instrumental type of thought is required, one that allows us to see beyond what the eyes can perceive, leading analysis to situations that, although not visible or even invisible, help us to understand problems. There are 8 elements we must take into account to develop strategic thought. 1. Consider the system as a whole, not as its parts. This implies a holistic, integrative vision. 2. There is a relationship between order and disorder, and changes of self-organization occur as a result of their interactions. Chaotic situations, from chaos to order or vice versa, are very real. For example, legal commerce often coexists with street vendors, or when recording a disc, the record label may first propose distributing it informally, and if successful, then move it into formal distribution. Everyday life abounds with examples. 3. A small event in one sector can cause tremendous turbulence in another, the butterfly effect. A single variable disappearing or shifting can cause impressive disruptions in sequence. 4. Maps, models, and visual images make it easier to see connections, relationships, and patterns of interaction. Creative visualization, graphic synthesis of knowledge, visual grammar. They communicate better than endless verbiage. For instance, a timeline can show at a glance what would take 10 pages of text. 5. Identify emerging conditions, paradigm shifts, and opportunities for innovation. Instead of seeing problems, view them as opportunities. 6. Nonlinear thinking is essential to recognize the keys to environmental changes. Think differently from other angles. Do not condition ourselves to traditional parameters, routines, or the way things have always been done, without imagination or creativity. 7. Perspective is important when we see chaotic events. See beyond what the eyes can see, never lose sight of context. 8. Think of 6 impossibilities every day. Finally, we arrive at anticipatory thought, born from the need to foresee possible or multiple directions of the future and be prepared for what may happen. This is even more necessary now, as we face situations of uncertainty where everything changes in an instant, and nothing is the same afterward. What is required is the exercise of foresight, anticipatory thought, to prevent premature suffering. A recent study affirms that what distinguishes us from other living beings is precisely our capacity for perspection, to think about the future. Research is the search to find, the search for information about something, the systematic search for an answer to a specific question. The scientist, the detective, the journalist, or even our neighbor, each answer in their own way the questions what, when, where, how, and why about events. And in our times, research can no longer stop at what happened. We must also ask why it happened. The questions in this new context are, what is happening? What could happen? What can we do if it happens? That it be well conceived, that is, that it be within a solid conceptual framework, that it be well integrated. Every well-integrated problem must contain as many questions as aspects that require investigation. That it be well formulated, the problem must be expressed in a proposition or set of propositions in which the contemplated variables or unknowns are clearly stated. That it be feasible, a problem must be solvable or researchable. That it be based on a theory, a problem cannot be scientifically addressed if it is not situated within a defined field of knowledge. That resources be available. The researcher must have the human, material, and economic resources necessary to carry out the investigation within an appropriate period. However, there remain enormous challenges for science, which still must study and discover much in order to fulfill its mission. Scientific research is an activity that makes it possible to obtain knowledge. That is, it is a process which, through the application of the scientific method, seeks to obtain relevant and reliable information to understand, unify, correct, or apply knowledge. Scientific research is defined as an activity aimed at solving problems. Its objective is to find answers to questions through scientific processes. And then comes the key question: why has science not been able to provide the answers humanity needs? 3 decades at the end of the last century were decisive in bringing about profound transformations, since from the 1970s onward, the changes affecting humanity occurred in a dizzying and increasingly accelerated way, identified by 6 C's: chaos, complexity, change, contradictions, crisis, and conflicts. We ended the 20th century with a profound crisis of scientific paradigms. Several reasons explain this decline. Because science has not been able to respond to humanity's search for greater quality of life and a reciprocal transformation of society and nature. Because the methods, schools of thought, and methodologies known up to that time proved insufficient to resolve complex problems and to unravel the issues posed by systemic structures that were already present by the end of the century. Because of the excessive compartmentalization of knowledge into fields that became more centers of power than scientific endeavors, turning science into disciplinary fiefdoms. Because the scientists clung to a supposed objectivity that clashed with the researcher's own condition as a human being. Every investigation is an interpretive exercise. Because of disciplinary arteriosclerosis that made it impossible to explain reality. Because scientific disciplines sought rigor, exactitude, clarity, and empirical references, rejecting any practice that lacked those characteristics, thereby becoming oppressive disciplines. Because no one wanted to face the answers to these questions. Who decides what should be investigated? Who does the investigating? Who pays for the research? Who uses the results? All this began to collapse in the last decades of the 20th century. At the same time, however, new movements were emerging that were linked more to action, practice, and praxis. That is, more to politics than to science. Problems became too complex to understand with a single lens and, worse, too complex to solve. Many of the scientific paradigms that sustained research were broken: speed and immediacy. Research dynamics and pace have changed. Faced with an influenza pandemic, for example, researchers can no longer spend 25 years studying an enzyme as before. Immediate attention is required, or else the world's population is at risk. The capacity and speed that computers now bring to work once done by hand are astonishing. Writing and citing references are no longer only in print but also electronic, with multiple new styles. Qualitative methods, particularly those from anthropology, have been given new importance. The study of perception and its influence on research is addressed. The supposed objectivity of science has been left behind. Unverified elements are accepted as valid, including attempts to recover the thinking of ordinary people and non-scientific knowledge. The future is studied as a way of confronting new problems. New discoveries about the brain teach us to think differently so that we can investigate through different avenues in a wide range of options. No more horses with blinders, eyes covered, walking in only one direction. New sciences have taken shape, some accelerated by technology and the tsunami of changes. Cybernetics, undoubtedly pioneering, gave rise to computer science, cognitive sciences, organizational sciences, molecular biology, neuropsychology, computational linguistics, control theory, artificial intelligence, intelligent life, intelligent agents, virtual reality, neural networks, fractals, the expanding universe, complex adaptive systems, biodiversity, nanotechnology, the human genome, expert systems, cellular automata, fuzzy sets and fuzzy logic, space biospheres, teraflop machines, and everything else being invented right now. According to some futurists, new specialties will arise abruptly. Today's disciplines are not even a third of those that will exist in the future. Many current careers are, of course, doomed to disappear or to be integrated into new forms of knowledge. A recurring theme is that many theories are giving rise to new sciences, such as chaos theory, complexity theory, and uncertainty theory, which provide us with information about the dynamics of the real world in which we make decisions and help us to anticipate and respond to change. Scientific disciplines have revealed their deep authoritarianism. With them, we have been unable to advance. They have curtailed the mutual enrichment of specialties and the integration of problems in order to solve them, concealing under a supposed struggle against indiscipline and interdisciplinarity what are in fact new pursuits of rigor in the knowledge of oppressive relationships and greater effectiveness in the action and activation of liberating relationships and bonds. Worse still, disciplinary separation, in addition to causing miscommunication, ended up harming the deep understanding of the very reality that science sought to comprehend and transform. It concealed causes, silenced effects, and substituted purposes. The isolation of variables, almost to the point of manipulating them in laboratories, separating them from their environment and from their relationship with other disciplines, has been damaging, as happened in economics. For example, the framing of events within rigid time and space parameters, as with functionalist methodology. The belief that knowledge is detached from power and commercial interests has even led to distorted partial studies of many events, stripping them of their sense of wholeness. Even mathematics, with its reign, has had to conceal the political manipulation of its data. Everything depends on how the accounts are made. Poverty figures, hidden or disguised, prevent us from knowing with certainty how many Mexicans in extreme poverty earn less than $1 a day, and how many survive on less, or on a minimum wage. Thus, mathematics serves power and the goals of those who exercise it. We are therefore faced with the need for a profound transformation in the traditional way science is conducted. The outlook is exciting, and much remains to be built. Pure or theoretical research and applied or practical research. Pure research is the study of a problem intended exclusively for the pursuit of knowledge. Pure sciences are those that seek to understand the general laws of the phenomena studied, elaborating broad theories to comprehend them, without immediate concern for practical applications of the results. Example: from the pure physical sciences arise branches such as mechanical and electronic engineering. There is no applied science that does not have behind it a systematic body of pure theoretical knowledge, and almost all pure sciences are constantly applied to solving concrete problems. Pure research develops the discipline in abstract terms, and generates general principles. As for applied research, also called utilitarian, it addresses concrete problems that require immediate and equally specific solutions. For example, a vaccine against measles. Applied research focuses on the study of a problem intended for action. Applied research can yield new facts. If we design our applied research well enough to trust the facts uncovered, the new information can be valuable and useful for theory. Applied research, in turn, concentrates its attention on the practical possibilities of putting general theories into action, and directs its efforts toward solving the needs posed by society and human beings. The resolution of practical problems is confined to the immediate, so its results are not applicable to other situations. Applied research may also integrate a previously existing theory. Problem-solving typically draws on many sciences, since the problem is something concrete and cannot be resolved through the application of abstract principles of a single science. Experimental research. Experimental research involves manipulating an untested experimental variable under rigorously controlled conditions in order to describe how or why a particular situation or event occurs. An experiment is a question posed to nature. In experimental designs, the researcher not only is practically able to conduct an experiment, but also has considerable knowledge of the nature of the phenomenon being studied. Rudolf Carnap stated that the experimental method is especially fruitful in fields where there are quantitative concepts that can be measured precisely. Experimental research has been carried out by psychologists working with animals or studying basic human responses such as perception or simple learning. Social psychologists also adopted experimental methods to study small groups in laboratory settings. The insights of Descartes, Newton, Kant, Pasteur, and Bacon who spearheaded the Great Revolution in knowledge from the 16th to 19th centuries, brought us 3 centuries of Cartesian rationality and positivist training that stalled scientific progress by leaving unquestioned the assumption that determinism and prediction could be elevated into mathematical formulas, even for feelings, motivations, ideas, plans, opinions, and worldviews, all of which cannot be directly observed. 3 great revolutions in the 20th century changed our previous parameters. Einstein and his theory of relativity, advances in quantum physics, everything contains energy called quanta, and chaos theory, which stressed the need to study not only harmony, but also chaos. From there comes the next step, to qualify, to value the subjective, to give importance to the whole, to the total system. That is what is holistic and universally ecological. It is not about denying the other, but about creating, recreating, and enriching what we consider so obvious, but in reality is not what we call reality. Elements, types, and characteristics of knowledge. Knowledge is acquired in various ways and at different levels of depth and according to different cultural approaches. Hence, its foundations are also multiple and varied. Knowledge is a human ability through which a subject who knows and an object to be known are related. The subject is the element in the act of knowing who receives and captures the impression, conceives it, and expresses it in an idea. The object is that which lies before the subject so that it may be known. The relationship of both is constituted by the act of knowing. Knowledge is, in itself, a relationship. Knowledge is obtained through 1. Experience, that is, the perceptions of the senses. 2. Reason, insofar as concepts and propositions can be inferred. 3. Intuition, a deep understanding of something by means of a quick intellectual vision, without the need for deductive reasoning. Have you ever asked yourself, why, if birds don't write, do they have so many feathers? Why does a kilo of feathers weigh the same as a kilo of lead? Is color a property of the object or of the observer? Why do we see through glass? Does the universe have the properties we attribute to it because we are the ones observing it? From the first question posed as a joke to the others that are the subject of philosophers and thinkers, knowledge is a constant search and is the means by which human beings manage to dominate nature and give answers to phenomena that at various times they could not explain. Anxiety in the face of the unknown is the main driving force of human beings to know. If at the beginning the first inhabitants of the planet did not understand storms, fire, or the sun itself, even now in the 21st century there remain many mysteries that surpass our understanding, such as the cure for AIDS, Ebola, the conquest of other planets, the potential of the mind, artificial intelligence that may surpass that of human beings, and many more. Knowledge is the bridge between reality and my perception of it, through reason and awareness. Knowledge, then, is a human ability by which a subject who knows and an object to be known are related. Elements of knowledge. Thus, we find the following elements of knowledge. 1. Reason, through which we obtain the first meaning of knowledge. 2. Cognitive activity, as the second meaning of knowledge, which takes shape in a process of concepts, judgments, and reasoning that form a mental image of the external world. Like birth itself, knowledge is not an isolated phenomenon but a process or series of successive interconnected phenomena that produce ideas. In relation to this process, it is usually accepted that the inner world is open to the outer world through the windows of the senses. By their action, the outer world enters the inner world where, without a doubt, it is immaterially captured by the cognitive faculty and is capable of producing an image of what is known and its concept or idea. 1. Knowledge is the result of the set of ideas, the result of the process of cognitive activity. Thought is a process of generalized cognition of reality. In the act of thinking, we form concepts that, in a particular way, reflect the objects and phenomena of reality. Knowledge always implies a duality of realities. On one side, the knowing subject, and on the other, the known object, which is possessed in a certain way by the knowing subject. The known object may, at times, be part of the subject who knows. Thought is intellectual knowledge. To know is to mentally apprehend, grasp, seize an object. Generally, apprehension does not occur in a single act but is the result of a series of acts. The subject who knows needs to move around his object. For there to be knowledge, there must be someone who knows. Knowledge cannot be stored outside of human beings. We may store information in documentary sources or in computers, but only humans can know. This implies that there is a material dimension of reality and a capacity in human beings to capture that reality and make it their own through knowledge. In summary, knowledge is made up of The subject. The element of the act of knowing who receives and captures the impression, conceives it, and expresses it in an idea. The object. Subject and object are etymologically two opposing words, both derived from the Latin verb jaceo, to lie, and combined with the Latin prepositions sub, under, and ante, before, meaning literally to lie beneath and to lie before, respectively. Their relationship. In knowledge, if we consider the object and subject broadly, that is, the external world and human beings, the foundation of their cognitive relationship has a potential character and consists in the property of external things of being intelligible and the capacity of humans to know them. Thus, knowledge itself is, in essence, a relationship. If, however, we consider the terms of the relationship strictly, the intelligibility of the thing and the external world of man, then the foundation of this relationship is actual and consists of the very act of knowing which establishes the connection between the two terms. Hence, knowledge itself is, in essence, a relationship. Knowing in its fullest sense culminates in judgment that affirms or denies an objective proposition. Not long ago, a questionnaire was distributed on the internet, and the first question was, how would you put an elephant into a refrigerator? Surely you stop to think. As a thinking being, you are searching for answers. Maybe you thought of a laser shrinker to make it small, or conversely, a giant freezer, or, in a butcher's display of imagination, cutting the elephant into pieces. Observe what is around you, but do not only see, perceive, nor only look, fix your gaze on something. Observe, consider attentively. You will realize that we extract knowledge from reality, and each of us, as individuals, as a social group, or as an ethnic group, interprets it in different ways. That is, we explain reality differently. Knowing is conditioned by the social, that is, by what other people have already known throughout history, and which is now transmitted to us through language. This has given rise to a type of common human knowledge that is transmitted orally, by intuition, customs, and traditions. The farmer knows it will rain because he has learned to observe the clouds and perceive the humidity. A mother knows what to do by identifying a certain type of crying in her child. Learned knowledge such as herbal medicine for healing or household remedies for different problems, such as removing stains, cleaning, or whitening clothes. All this is known as empirical knowledge. Notice carefully, the process arises from concrete thought, common sense logic, simplicity, and obvious situations that are solved in a simple way. If we look into some of the sacred books of antiquity, or even the myths of non-literate peoples or the works of the first philosophers, we will see that in all cases appear, albeit without rigorous order, both lucid and profound reasoning and practical, empirical observations, feelings and aspirations together with intuitions, sometimes brilliant, other times deeply misguided. All these constructions of the intellect in which the passion and sentiment of those who built them are also poured, must be seen as part of a process rather than as a repository of countless errors, since they demonstrate the first approximations in the search for pure truth. The analysis of many cases would prove that we must always in some way pass through mistaken knowledge, illusions, and deceptive impressions before being able to exercise criticism on them, which then allows us to elaborate a more objective and satisfactory knowledge. The abstraction of knowledge, on the other hand, leads us to complex thought. Scientific knowledge surpasses ordinary observation and personal experience, and has certain characteristics that distinguish it from everyday thinking and other forms of knowledge. Objectivity. It goes beyond the singular data of the subject's perception, subjectivity. It does not remain in internal data but externalizes them with the category of general validity. Objective truth clarifies and specifies the object of knowledge with general validity. It is objective insofar as it seeks to reach factual truth, independent of the values and beliefs of the scientist. Verifiability. It uses empirical verification to answer posed problems and to support its own claims, demanding constant confrontation with reality, even problematizing what has already been accepted. Fallibility. It indicates that it can fail. Scientific truths are not unquestionable. The tasks of knowledge never seem to end, rejecting absolute, closed, eternal truths. In this sense, it is also progressive, since by not taking its conclusions as infallible and final, it remains open to new contributions and the use of new procedures and techniques. Systematic nature. It is methodical. The wise person does not ignore that beings and events are linked together by certain relationships. Its goal is to find and reproduce this chain, achieved through knowledge of laws and principles. For this reason, science constitutes an integrated system of data. Knowledge proceeds with order, plan, method, or system, which allows it to establish truths valid for all. It is through the passage from the abstract to the concrete that the process of scientific knowledge is carried out. This type of knowledge requires a high level of abstraction, complexity, and interaction of inferences, in such a way that we may interpret reality with diverse instruments and along different paths. We face
San Diego Global Knowledge University, Education Beyond Boundaries.